Okay, so today we're doing 5.3 and we're looking at inequalities in some geometry. So kind of some fun stuff. First thing we're going to do is apply the properties of inequality to the sides and angles related to a triangle. And two, we're going to learn two new theorems and apply those. So we're going to apply the greater angle theorem and the longer side theorem within a triangle. So first up, the comparison property. So for any number, real numbers, a, b, and c, if we have a equals b plus c and c is greater than 0, then a is greater than b. Okay, so do we get that? Like just in making a comparison? Good? Okay, so we want to use that here for that. And it says use greater than, less than, or equal to complete each conclusion. Then name the property used to reach that conclusion. So in the first one, if the measure of angle XYZ is equal to the measure of angle 1 plus the measure of angle 2, then the measure of angle XYZ is what to the measure of angle 2? So I have down here, it's the greater than. So, I mean, I would simply put that greater than in there. Because if we're adding the angles and it's equal to 1 and 2, then the whole thing has to be greater than the part. And that's that comparison property, what we just did here. How about B? This time we're looking at sides. So if XP is less than XY, okay, so XP is less than XY, and ZP is less than, so ZP is less than ZY, then XP plus ZP. So if we add this side and this side, what do you know that is comparison to XY plus ZY? Greater, okay, X, Y, and Z, Y would be greater. So what symbol would we put in there? Less than, you got it. Absolutely. So that would be less than. And I don't know if you're going to get the property of this one. What is the property of this one, do you think? If you go down below where it says the properties of inequality, it's one of those down there. What did you do in B? Did you add, multiply? Added. So this is the addition property of inequality. So the addition property of inequality. Very good. Like I said, that one's a little bit tougher because we hadn't really talked about it yet. So I'm like, it'll be okay. So let's look at those properties of inequalities. We've talked about them as properties of equalities. But if we look at them this way, so if we have A is greater than B for addition, and C is greater than or equal to D, then we're getting into some addition. Then A plus C has to be greater than B plus D, because we're combining the A and the C together. In multiplication, there's actually two parts to this one that's just a little tricky. So if A is greater than B and C is greater than 0, then A times C is greater than B times C. On the flip side of that, if A is greater than B and C is less than 0, what's a number less than 0? -1, okay, or 1/3, okay, a fraction even. All right, if that's the case, then A times C is going to be less than B times C. Multiplication gets into that little bit of trickiness. Transitive property Okay, that's when we're transferring what we know about one thing to another. So if A is greater than B and B is greater than C, then we know A is greater than C. Okay, we're able to replace that. It's a little bit easier to think about with equalities than inequalities. The trichotomy property means that there's only 3 possible options. A has to be equal to B, A has to be less than B, or A has to be greater than B. Those are the only 3 options we have when we're comparing 2 numbers, as it has to be one of those. Okay, questions so far? Nope, I like it. All right, so the exterior angle inequality theorem says the measure of an exterior angle, okay, so we're talking the exterior angle of a triangle, so angle 1 out here is the exterior, is greater than the measure of either remote interior angle. Where are my my remote interior angles? It's not A because A makes a linear pair, right? If this is my angle right in here, right, this distance, this angle is not remote, it touches it. So it can't be the remote angle. Which are the remote angles? B. Good. B and C are the remote angles. So we can say angle 1 is greater than angle B, and angle 1 is greater than angle C. Because we also know we have the remote interior angle theorem from earlier, where if we add B and C, it equals the remote or the exterior angle. All right, very nice. Then let's keep on moving. You're doing awesome, Lucas. All right, next up we have the greater angle theorem. So if 2 sides of a triangle are not congruent, the larger angle is opposite the longer side. Ooh, that's kind of nice, right? So the larger angle is opposite the longer side because they're all connected. So if BC is greater than AB, okay, so AB. So let's put a 1 here and we'll put a 2 mark here. Then the measure of angle A, because it's opposite of BC. So this is larger than the measure of angle C, which is opposite of this one. Okay, because there's always that relationship between side length and angle measure. Does that make sense? Makes sense on paper, right? Until we have to like use it in a proof, and then it may not make sense. Or how we apply it may not make sense. Okay, so example 2, list the angles of the triangle in order from smallest to largest. Okay, so what's our smallest? So first question, what's our smallest or shortest side? MN is the shortest side. What angle is opposite of MN? L. So angle L is the shortest. And then what? Angle N, because it's opposite of LM. Good, so angle N. And then what's your last one? Angle M. Because the sides that relate are 12, 13, and 14. Those are the opposite side lengths. Good. Nice work. Okay, now we have the longer side theorem. So if 2 angles of a triangle, so we're talking the angles now, are not congruent, then the longer side is opposite the larger angle. So this is just like the converse of the other one. So if we say the measure of angle A is greater than angle C, okay, well the side opposite of A is BC. So BC is greater than AB. So that's kind of nice. All right, and the last part there that goes along with this longer side theorem is the hypotenuse. Okay, the hypotenuse is the longest side of a right triangle. Okay, these are some other theorems that come from that. So the hypotenuse is the longest side of a right triangle. What's the angle? How big is the angle opposite of a hypotenuse? Yeah, how big is the angle that's opposite of a hypotenuse? 90. Excellent. Good. All right. And the other theorem that comes out of this is the shortest segment from a point to a line is a perpendicular segment. So the shortest segment from a point to a line is the perpendicular segment. So we've also talked about that, kind of. We haven't stated it, but we've talked about it when we did our orthocenter and our circumcenter, right? Because any line on that bisector is they're equidistant, so it's kind of the same thing. So any point from there to it, to the line, is perpendicular. Any questions? I was like, today seems pretty quick, right?